Okay, so now that you've found your LLC setting, you're going to start bitting your chip, writing down what your findings are as you go, so that you can learn your combination of hardware and how your chip is performing and voltage scaling. Your FCLK or system agent clock on different motherboards will default to either 800 or 1000. So just keep an eye on that. Some motherboards might require you to pull that back to 800 to even do this. Now, you set your voltage, your core voltage, at 1.100, and you've already done your LLC setting, so anything you do when you load it up should have minimal V-droop. So what you do next is at your base voltage, base clocks, sorry. So on a Skylake 4.2 with a 4.1 cache, you go and you run Cinebench. Now, if it succeeds in running Cinebench, then that's fine, good, okay, it's done that. You go and then run the benchmarking stress test on XTU. If it makes it through both of those, then you can go on to the next stage, which would be to just turn up your base clock to 4.3 for the example of a Skylake 6700. You continue to do the same thing. At some point you will probably run Cinebench fine and you won't run XTU, so you know that you're probably going to need a little bump to get yourself up through the XTU. So you're going up at 0.01 volts at a time until you get that stable again, and then back to upping your core clock, running Cinebench again till it succeeds, XTU fails, and then you run your voltage up another 0.01 or 2 or 3 or whatever it is that it takes in order to get it stable. There will reach a point where you have hit your sweet spot. Now, it could be, I mean, generally around, if you want to do a shortcut too, this is a way to do it. You can go straight to 1.35 volts. I don't advise you do that. I think you should start from 0.1 and understand your chip and see if it's a bad chip, it will start needing a lot more volts early on. If it's a good chip, it will start needing a lot more volts later on. I mean, for example, an average chip, 1.35 volts, 4.5 core, leaving the cache where it is, maybe 4.6. A good chip will hit 4.7, a great one will hit 4.8. So at some point you'll see where you have to start putting a lot more voltage in it to keep it stable. You run the Cinebench and then the XTU, because the Cinebench gives you an indication when the XTU fails of how far away you are, how close, you know what I mean? It just sort of, you get to get a feel for your hardware that way. So yeah, I mean, it'll get to a point where you'll say do 4.6 at 1.35, 1.37 volts or something like that, and then it'll take you know, like 1.440 volts in order to get up to the next level, something in that line. Now keep in mind that later on, when you do your RAM, which is really your next stage, you leave the cache until after the RAM. That the internal memory controller on the chip will be under more stress, and in order to get memory stable, you might need to give it a little bit more of a bump of V-core anyway. We get to that later. So at the moment, just see where you can get your chip to run at a temperature under 85 degrees in that little box at the end of an XTU run, leaving your core where it is. There's a few other little things like, I mean, all BIOSes are different, and all of them are, some of them do things for you, some of them have got a setting for everything and you have to do it your bloody self. The more complex the board, the more the setting is up to you. Some of the gaming boards will do things for you. For example, my old ASRock Z170 would put the turbo boost power time window at 1 second at all times. On this board it'll generally default to 8 seconds, and I would have to in BIOS change it to whatever seconds I want it to be. So there again, you got to learn your motherboard and understand it, and you should still read some other stuff. But that's how you bin your chip to find out how good it is and where it is. If you can get to 5 gigs on the core at under 1.475, you're doing exceptionally well. I mean, bit of a rarity. I've known people to do it though, so mine, I wasn't blessed by the silicon gods. A lot of the guys out there that are on this site that I'm showing things to have got superior hardware to what I'm running at the moment, plus I've got a bit of a problem with my chip. Won't bore you with those details. I have to take control of it manually. If I set it at auto voltages, they're ridiculous. But this is the early stage. This is actually quite the easy part, is binning your CPU chip. That part's not hard at all. It's later on when you have to start adjusting IO and SA voltages to keep your memory stable or your cache settings stable or whatever, that it gets a bit more difficult. So do this early bit that's really quite fun. Now keep an eye on this. I'm not very good with this shit camera anyway, shit phone. These voltages here, as they pertain to what you've set in BIOS. So you'll notice that, say, you've set 225 in BIOS for your IO voltage, your VCC IO, IMC voltage, and it'll show as 1.152 in Windows. Could happen the same with VCCSA, your system agent voltage. There's a lot of other little settings there that'll won't say here what is the same relation to what it is in voltage, and you might have to do a little bit of searching to find out the correlating voltage and what it's called. Yeah, I think that's all I really need to say at this point in time. Yeah, that'll do it for this one. Just see where you can get your chip up to using that method, and we can move on from there. The most important part of an overclock is really getting your RAM right. So till next time.